Here is my video tutorial on electrostatics. First things first, what is electrostatics? Electrostatics is the study of stationary electric charges or fields as opposed to electric currents. Now, what is an electrostatic charge? An electrostatic charge is the charge flowing through conductors, which we would usually call electricity. Electrostatic charge can also be present on insulators, and because these materials do not allow the charge to flow, meaning that it stays still. Now, there are two types of charges. The first is a positive charge. This emits its energy outwards. The other is a negative charge, which draws energy towards it. This is known as electric fields. The behavior of charges begins by saying that two of the same charges cannot be combined. However, two opposing charges can be joined as they attract each other. If there are two parallel plates with the same opposing charges on each, electric field strength will simply be equal, as presented by the arrows. Easy examples of this process is with two magnets. Magnets are known to join to other magnets, but they must be of opposing electromagnetic charge. Another example is with genders. Opposite genders are attracted to each other, usually. This is known as a Coulomb. Coulomb's law states that in order to find the electric field, you must divide the electric force by the charge. The units for this is newtons over coulombs. An example would be if we had a force of 2000 newtons and a charge of 1 millicoulomb, the answer would be 2000 newton coulomb to the power of -1. If we want to go further, we can find the force between two charges with this equation of Coulomb's constant times charge 1 times charge 2 over the distance squared. An example for this equation would be if we have a positive charge of 5 times 10 to the power of -3 and negative charge of -10 times 10 to the power of -2, 0.5 meters apart. Coulomb's constant for these equations is 9 times 10 to the power of 9 Newton meters squared over coulombs squared. Now, if we substitute this into the equation, it would be the constant times charge 1 times charge 2 over the distance squared. This will then be minus 45 times 10 to the power of 4 over 0.25, which therefore equals -180 times 10 to the power of 4 newtons. Because the overall force is a negative, this means that they are being attracted to each other as it's a negative charge. Now, moving on. Electric current is the flow of electric charge. It is measured in amperes, which is the flow of electric charge across a surface of 1 coulomb per second. This can be displayed from the red arrows in this series circuit, as the charge travels from the positive side of the battery and returns through to the negative. Electric currents produce magnetic fields, and an easy way to determine the direction of magnetic fields is using the right-hand rule. As the magnetic fields surround the current, they either go into the page presented by the X or out presented by the dots. To find this, you point your right thumb in the direction the current is traveling, and the direction of the magnetic field will be shown by your fingers as they curl over and point over it. like so. The last characteristics of a charge is the direction they travel through the electric field. A positive charge will go the same direction as the electric field. However, a negative charge will travel the opposite direction as the electric field. This links back with our previous circuit, as the arrows will be presenting these characteristics of positive and negative charges. That is it for this video. Thank you for watching. By Sebastian.